And 14 hours ago, NASA's Jet Propulsion Laboratory confirmed something that should not be possible. Earth's orbital position has shifted by 3,000 miles. I'm talking about a measurable, documented displacement in our planet's trajectory around the Sun. Not from an asteroid impact, not from a solar event, from 3I Atlas, a comet. Let that satisfactorily sink in for a moment. An interstellar object, discovered just months ago, has exerted enough gravitational influence on Earth to alter our orbital path by nearly 5,000 kilometers. The probability of this occurring naturally, NASA's own modeling puts it at 0.0003%. That's 3 in 1 million. Picture the scenario clearly. You wake up this morning. The sun rises at the same time. Your coffee tastes the same. Everything feels normal. But Earth is not where it was yesterday. Our planet has been nudged, pushed, moved, and the object responsible is still out there. ESA's Gaia spacecraft independently verified JPL's calculations at 2217 UTC last night. Two separate space agencies, two completely different measurement systems, two identical conclusions. Earth's orbit has changed. Now here's what makes this genuinely terrifying from a physics standpoint. I Atlas is currently 287 million kilometers from Earth. At that distance, the gravitational force it could exert on our planet should be negligible. We're talking about influence that shouldn't register on our most sensitive instruments. But it did register. It registered so clearly that NASA issued an internal priority alert within 90 minutes of confirmation. When I first examined these numbers, I had to verify them 3 times because the physics here breaks every model we have. For cometary gravitational influence, think about the precision required for this detection. Earth orbits the Sun at approximately 107,000 kilometers per hour. We travel nearly 2.6 million kilometers every single day. And within that enormous daily journey, instruments detected a 5,000 kilometer deviation. That's like measuring a human hair's width from 100 kilometers away. The measurement is real, the displacement is documented, and the implications extend far beyond orbital mechanics. Because NASA has now confirmed what many feared, the seasonal patterns Earth has maintained for millennia are beginning to shift, not dramatically, not yet, but measurably. Winter arriving 6 hours later in the Northern Hemisphere. Summer heat patterns extending beyond historical boundaries. Agricultural growing seasons that no longer align with centuries of human planning. All from one object. All from 3I Atlas. And what I'm about to show you in the coming sections will demonstrate exactly how this happened. What the data reveals about this object's impossible properties and why the scientific community is now operating under protocols reserved for planetary scale events. And the orbital shift is just the beginning. The real question is what else 3I Atlas has already done that we haven't detected yet. To understand what we're witnessing right now, I need to take you back to the moment everything changed. September 14, 2025, the Atlas Survey Telescope in Hawaii detected a faint point of light moving against the background. Stars. Initial classification suggested a distant asteroid. Routine observation, nothing unusual. That assessment lasted exactly 72 hours. By September 17th, astronomers at the Minor Planet Center noticed something deeply wrong with the trajectory calculations. This object wasn't orbiting the Sun, it was passing through our solar system. Hyperbolic trajectory, interstellar origin confirmed. I Atlas became only the third confirmed interstellar visitor in human history. Think about that designation for a moment. In all of recorded astronomy, across thousands of years of watching the skies, we have identified exactly 3 objects from beyond our solar system. Satu Oumuamua in 2017, dua ay Borisov in 2019, and now Tiga ay Atlas. But here's where the data diverges from everything we know. Oumuamua was strange. It accelerated away from the sun in ways we couldn't fully explain. Borisov behaved more like a traditional comet, outgassing and following predictable physics. Scientists expected 3I Atlas to fall somewhere between these 2 profiles. It did not. NASA's Deep Space Network began tracking 3I Atlas on September 29, 2025, using the DSS-43 antenna in Canberra, Australia. The initial mass estimates came back at 4.7 trillion metric tons, enormous by cometary standards, but not unprecedented. The gravitational influence readings, however, were unprecedented. On October 15, 2025, at 3:41 UTC, NASA's tracking systems detected the first orbital perturbation. Earth's position deviated from predicted models by 340 kilometers. Instruments recalibrated, measurements repeated, same result. ESA's Space Debris Office in Darmstadt, Germany, ran independent calculations. Their number came back at 347 kilometers, within measurement tolerance. Same anomaly. The Subaru telescope on Mauna Kea cross-referenced using optical tracking methods. Their deviation reading registered at 338 kilometers. 3 independent sources